Thank you. I'm Timoni West, and I'm the director of XR, which is to say AR, VR, MR research at Unity Labs. And I'm going to be talking today about the tools that we are making for spatial computing, which runs the gamut from everything from augmented and virtual reality to some incredible new embeddables of the future that we'll have someday. A lot of times when people think about Unity Labs, they think about us being primarily virtual reality focused. That was a big part of the first few years. But I want to start with a video that actually showcases a few of the different projects that Labs is working on. It's not just virtual and augmented reality. We also do machine learning. So without further ado, let's play the video. There should be some sound. Yeah. Okay, that's the video. All right, so my group focuses entirely on XR, but we're called the Authoring Tools group, and that's because Unity itself is primarily an authoring tool, and we try to make tools that are for the medium, for the future, but still in the spirit of Unity. So one of the biggest projects we worked on over the last 2 years, which you saw in the video, is called Editor XR, which lets you take your regular Unity scene and author in it, and my slides are out of order. So this is our projects for 2018. Let me go over them quickly. Ontological metadata for semantic creation, which is a fancy way of saying, you speak it and a cube comes to life, or even more complicated interactions. Authoring tools for spatial computing, which I'll dive to in a second. Graphics research. Actually, one of our lead graphics researchers just won Best in Show for a paper published at Siggraph. Humans captured at rendering, and artificial intelligence for NPCs, including behavior planning and animation. All right, so now let's dive into Editor XR. So all of you, I'm sure, know what Unity looks, or most of you. Actually, do any of you not use Unity today? Okay, a few people, but most people are aware of it. This is a pretty conventional way of interfacing with 3D objects today. You have a gizmo, you usually have keyboards, buttons that map to translation, and you're sort of working in 3 dimensions, but against like sort of a sheet of glass that's always between you and the 3D digital world that you want to work with. So we really were excited to explore actually creating 3D in 3D. It seems like a no-brainer. So Editor XR is an open source extension that you can download on GitHub today that lets you stereoscopically render and edit the scene view in Unity. And that's what we've built. And I want to go over a little bit of the challenges that we had when we were making it, because in your head it sounds like a great idea and like something that would be extremely easy to map, like what you think you can do, you can be able to do. But the biggest difference between the real world and working in Unity is that in Unity you can do anything you want. You are God, you can lift up objects of any size, you can move objects any amount of distance. And this is not how humans are designed or even are able to interact with the real world, which leads to some funny challenges. Another big challenge with this is that we needed to make sure that we couldn't have significant limitations on what the user could do. If you could do it in the scene view in a conventional 2D UI, we wanted you to be able to do it in 3D. And again, this means that you have to have people be able to create very tiny scenes and huge scenes and be able to manipulate them both by scaling or snapping or whatever it is they needed to do. So let's walk through. In this particular case, it's doing that thing where it doesn't want to play the video. Let's see, try it again. Damn it. I wonder if I just go back out into this mode and you can see my notes, and maybe I could just play it from there. Anybody recognize the background? Ghost in the Shell comp art. Yeah. All right, let's see if I can just play from here. Okay, wow, it really doesn't want to play. Huh. All right, so this is just a very quick overview of what you can do on the control level. So we have two different kinds of manipulation. You can actually reach out directly and grab things and manipulate them, but you can also manipulate them using a gizmo that would feel familiar for 3D applications like so. So now you're moving along an axis. You can also move and rotate objects on the axis as well. You can also move them on planes, because it turns out that you can just pick up and move things around the way you can in real life, but very often you're going to end up moving an object accidentally just off by a few degrees exactly the way you didn't want to do that, and it's very hard to course correct. So we ended up needing to have both types of manipulation. All right, I'm going to try to go back into present mode and see if the next video will work. Fingers crossed. Well, now it works. All right, here's another example of something that was a lot trickier than we expected, and this is snapping. So in the real world, you basically get one type of snapping, and that is gravity. That is the only way that you can get two objects to connect to each other in a typical way. But when it comes to digital worlds, you have a variety of ways. Maybe you want objects to snap and rotate as they go along, a planular surface. Maybe you don't want them to rotate and you want them to just go like this. Maybe you want to snap to ground, or maybe you want to snap face to face, or maybe you want to snap medium to medium. So we ended up with actually, I think we have a combination of 18 different ways for you to be able to snap in Editor XR. So this is, I think, the snap to ground. We also had to do a ton of work on easing. When does it snap and when does it feel like it can snap away? So it actually snaps much more closely to, in this case, the nearest face. This is sort of snap with free rotation, than it does when you lift it up. In other words, if you put something on the ground, it'll snap about an inch away, let's say. But if you want to pull it off from the face that it snapped to, you have to pull it about 3 inches. Or I guess we're in Canada, so I'll say 10 centimeters versus 3. But you can see here that this is one of our developers who actually worked on the snapping system, and it can have some, if you're not aware of what mode that you're in at the time, it can have some interesting, right, things that maybe you didn't exactly want it to do. And so you have to be aware of what snapping mode you're in and when you want to be in that snapping mode. And this is not a way that people are used to thinking about moving things around in Unity or in virtual reality or in general. So we want to give people the ability to do this, but we understand it's a new paradigm. Another big thing is that we want the UI to be fairly limited, because in your virtual world, you tend to have a ton of digital objects and visual clutter anyway. So making sure that we don't have significant cognitive overload, but also making sure you know what mode you're in is a big tension with professional tools for virtual reality. We also had to come up with an entirely new type of window. This one doesn't exist in regular Unity per se. It's called the mini world. I guess it's kind of the equivalent of if you had like 2 scene views open side by side at different scales. So the mini world allows you to play. Okay. The mini world allows you to be in the same world at the same time, interacting with things the same way. I think it might just be direct selection, no gizmo. But you can pick up objects that are far away from you. Right there, he just moved himself. And then you can take objects and put them in another mini world. So you can just have multiple worlds available at the same time. Now you can do this with VR creation tools just by world scaling, but we thought that there was a significant advantage to being able to see the world in multiple scales at the same time that you were in whatever your final one-to-one would be. This is just like a little preference of mine, but I think when you scale in and out of things in virtual reality, how many of you have tried tilt brush or medium or blocks or, okay, most of the room, I figured. I feel like that gives you a little bit of sense that it's not entirely real. And so I think there's something really nice about being able to do manipulation like this, but still feel like you're in that one-to-one scale. But that's just, again, personal preference. You can scale the world as well, just like you can in tilt brush if you want to. In fact, we emailed them and asked them if we could steal their scaling interface, and they kindly let us do that. So. All right, and this is a sneak peek at a new type of UI that we're coming up with. I'm going to play this twice. So this is called the Spatial UI system. You hold down the secondary trigger that grips on your controller, and it allows you to very quickly go between different types of quick interactions, things like cut, copy, paste, and also different tools that you're working in. So for example, here they're working in the primitive tool, but then they want to switch to the annotation tool. You just hold down the secondary trigger. The interface will appear in front of you wherever you're facing, and all you have to do is move your arm in any direction. We actually don't take direction into account. You can move the same direction that feels natural, but you can actually move in any direction, and we'll still just treat it as a linear and move through the menu. And the reason we did that is twofold. First, sometimes you're physically not able to go one direction or another, like you're just trapped at your desk or in the space, or you might punch your monitor, which is something that we do all the time. Or sometimes, people. Proprioception is not perfect. People don't have one-to-one mappings exactly, and we've tried enough gestural stuff in VR to know that we needed to have it be pretty forgiving in order for it to work. So let me just play this one more time, so you see it again in context. We also have a lazy follow on this, so it appears where your head is, and it won't follow if you move until it gets to a certain breaking point, and then it'll kind of lazily swoop in behind you. If you have a heads-up display and it follows your HMD one-to-one, it feels absolutely terrible. The whole Iron Man thing is a lie, basically. We thought about that, and my theory is the reason is that nothing in real life follows your head so closely. It just never does. It's impossible, like physically, unless you have something in your eye. So it intrinsically feels like just something is stuck to your view. Okay, so Editor XR. It is, like I said, available on GitHub, open source. We take contributions back from the community. The Spatial UI will be out within the next month or so. And special announcement, we're also coming out with a runtime mode. So if you want to use any of our snapping tools or selection tools or the 6 different kinds of locomotion tools or any of the UI, you can actually use it in your own experiences in runtime. So that'll be coming out over the next few months. All right, so now I want to talk about AR and mixed reality, which has been the focus of the Authoring Tools group for 2018. Our new project is called Project Mars. It is a mixed and augmented reality studio. I didn't come up with that acronym, but we think it's a great acronym, so we're going with it. It's in a Unity extension, just like Editor VR, and I'll walk you through it. How many of you actually work in augmented or mixed reality today? How many of you done work, like HoloLens work? Okay, and Magic Leap, maybe. Okay, that one guy, cool. Okay, so mobile AR is fairly simple today. You can find a plane, maybe you can find a few different planes, but that's really all you're looking for. You don't have a lot of information about what's in the world other than what you get from your mobile phone's camera feed. And that's an amazing, landmark for computer vision, but it's not your computer knowing a lot about the world to be able to do anything with it. So when we started thinking more aggressively about the future of mixed reality and augmented reality wearables, when we're all in the same shared space, hopefully calibrated and somewhat social, what do we need to do in order to make sure that developers can make apps that work in a variety of spaces really easily? And we immediately just had a whole bunch of stuff that came up that made no sense. So for example, it's fairly uncharted territory. There aren't a lot of augmented reality tools that do much more than publish to web at this point. A lot of it is kind of 2D stuff that's just been sort of moved over into 3D. Another big thing, and this is probably the biggest one that I harp on a lot, is that in almost any flow that you can think of for 3D creation today, any sort of world building tool that you have, you know the position of every single object in the scene. You know this by default. You might have some like randomness or noise in there, but if I click on an object in Unity, I know where its position is in world space down to the 10th decimal. And this is true of all things related to computing. But when you are in a mixed reality environment, like let's just imagine that this is a projector that is augmented and there's cool augmented art on the walls and someone has a cute little augmented reality dragon on the floor right there. Where it is positioned is relative to world space only, right? And unless you have a one-to-one perfect mapping of the space that updates every millisecond, you're never going to have an entirely accurate view of what your scene view is or your game level, if you want to refer to it as that. So what we realized we needed to do is make sure that no matter where you are and where you're trying to run your experience, no matter all of the millions of bedrooms across the world where you have a bedtime story app, it would need to run pretty well in all of these different spaces. And we need to allow developers to do that really easily without having to script the whole thing. So that's what we're working on with Mars. Another big thing is that you, unless you're Santa Claus, cannot visit every house in the world to test your app, right? You can't visit every living room. You can't visit every outdoor park. So you need to be able to test test how your augmented or mixed reality app will work. I'm just going to say augmented reality. I hope no one's offended by that, but it's just like a lot of words to say over and over. You need to be able to test against a variety of spaces that you might not even think of. Right, so we need to have simulation views, and we need to have you be able to pull in data that you have from scans or LiDAR or CAD files, whatever. And you need to have all of the information, as much information as you possibly can about the world in order to be able to edit directly. So if you want to do something that's location-specific or site-specific, you need to be able to pull that into Unity and edit against it without having it be part of your build. Except in one unusual case that I'll mention later. And machine learning can help with a lot of this, but large-scale data sets for things like room simulations are just not widely available yet. They're not available in the consumer market. They're not in academia. They're not even like, there's no private versions that we know of. So this is just really new territory. OK, so this is what we announced at Unite Berlin. This is what Project Mars looks like in the editor. Did any of you see the announcement for this? OK, a few people. All right. So I'm going to go through this quickly, but a lot of this is changing, and I'll talk about why too. But basically, the new things are that we have a new view, the simulation view. And in this version of the simulation view, it has a dummy room. We've just set up a ton of different rooms, and you can just funnel through all the different rooms to see object placement. So that's one of the first things. The other thing is now you have a way to define what we call fuzzy placement of objects in the space. And this can be sort of cascading or hierarchical or relationship-based. I'll go into that more as well. But on the left-hand side, you see that you have this spaceship, and one of the gizmos is highlighted, and this is the plane size gizmo. So you have a minimum and maximum. Find a maximum size of, say, like 10 feet, but it has to have a minimum size of, say, like, 1 meter. And when you find that, place this spaceship on the bed, because this is a bedroom experience, and you want it to be placed on the largest and main object in the room. And then put the trees over on the ground, and put some more of the scenery stuff in other odd locations. So the idea is that this experience ought to work in any bedroom or living room with sort of a large sofa. That's what we're going for. We're trying to get you to be able to create stuff that roughly maps to where you think it should go, where the best placement could possibly be. In the scene view, the simulation view, you'll see that we have a new hierarchy. This is just for, these are not objects that exist in your game or in your movie or your app or whatever you're making. These are just objects that exist in the simulation view for you to test against. And if they're what we call AR objects, they're indicated by the blue diamond, and then they have the blue glow. And then over on the right-hand side in the inspector, you see we have something called a Mars entity, which is a collection of conditions. So I just said a bunch of words, so let's quickly go through what I meant by those words. So conditions are what you're generating by drawing out all of those placement types with your gizmos. So conditions could be anything like angle or proximity or an event trigger if you want. When two users look at each other, send a high five to each other, for example. Those are all conditions. And they specify what the Mars entity will actually do. Mars entity is a set of objects, or sorry, a set of conditions. And this is what it looks like in the inspector. So queries are basically the question that is asked. Like, you have a set of conditions, the query goes to the database and says, did we find those conditions, and yes or no. And then relationships, I touched on this a little bit. They're a group of AR objects that'll have some kind of connection. And this is really useful if you're trying to lay out, say, like a really robust responsive experience where you want to have the castle in the middle of the room, and after that is placed, then you can start placing all the bad guys around it. So you don't place the bad guys first. And this is important because especially with things like augmented reality on mobile, you can't get the most important stuff first unless it's in the camera view. So if you just start here and looking at the floor, you will know much more about sort of a boring part of the room than the part of the room you want to know about. And we need to make sure that you can say, look, even if you find a ton of information about the room, make sure you know even more information about the room before you start setting up, your Netflix app. So that way, if you have a Netflix app and you want it to be pinned to the largest wall in the room, you can make sure that enough rooms are scanned before it places the wall. Again, this is kind of counterintuitive. This is not how consumers think about mobile AR today. But I think, in the future, when we do have near instant meshing and scanning of room spaces, this will be fairly instantaneous. It just needs to be built for developers. All right, and sets. Sets are basically all of the properties and qualities that are the queries and conditions and everything else that will, instead of gameplay, will define the placement of all of the objects in the space. We also had some conversations with the Microsoft Flare team, who wrote an excellent paper I highly recommend back in, I think, 2012, 2014. And they were doing some work around flexible object placement as well. And one thing that they had that we hadn't thought of yet is that because they had an entire room scan to begin with, they could have objects that could reference not only their own placement, but then inform the placement of other objects. This is something that we hadn't really thought about before, but I think is worth exploring as we dig more into it. So we'll see. We're going to do some alpha testing and see if people want to go that far yet. One thing about Mars is that it's a little aspirational. We think today that a lot of the mobile and AR and wearable AR could be a lot cooler and a lot better. And the reason why people aren't doing it, we hear time and time again, is simply because it was too hard. It was too ambitious. They ran out of time. They ran out of money. It was a one-off, right? So we want to create the systems that underlie this so everyone can just go and make great stuff from the beginning. So after Berlin, we took a look at what we built to see if it still made sense. That was our kind of moment of, we've tried it, we've built things with it. What else do we need to do? And with this current view, we kind of had an interesting question around what is reality and what is reality and digital reality. So we have these Mars entities. They are also a game object. Game objects have a transform in world space. They have a position. This is an inherent quality of Unity architecture. But these digital objects, the way we're treating them, do not have a world space in Unity property. We just have to ignore it, because it doesn't matter where it is in Unity. It doesn't matter where it is in the scene view. All that matters is where you end up with it in the room. And sometimes they may match, if you are doing a one-to-one and you know what the room or space looks like that you're editing for, but often it will not. So, and we also had other different demos and proof of concept things. This is procedural terrain, or procedural level design generation. Some work around image markers and geolocation information combined with image markers and geofence stuff. So these are all things that are features that we're also building out right now. But in terms of the problems that I just mentioned, we're actually considering, this isn't decided yet, but I love at talks when people talk through the process. So I'm trying to bring you along as the team is actively deciding this. Do we want to stay with the simulation view that's separated from the scene view, or is that a little too weird? Is that a little too not Unity? Or should we just make it a simulation mode that you can quickly swap between? The new prefabs view in Unity also has an isolated view for specific types of object editing that doesn't relate to the game itself. So we're wondering if we shouldn't go that direction instead. So sneak peek, this might be the updated view of what Mars looks like in the future. So this is the interface side. There's a couple of other things that we're working on now. For example, actual tooling on device, both for mobile devices and for wearables, where we're going to target the HoloLens and Magic Leap first. But we also need to talk about the data, because when it comes to augmented reality, the world data that you get is the biggest piece of the puzzle. That is directly what informs the quality of your experience overall. If you have shitty information about the world, it doesn't matter how great your experience would be, it's going to just fail. I have an app on my phone that I can't get to work because my phone never wants to find a vertical plane. I don't know how big a vertical plane they're looking for, but it just won't run. Like, I never have been able to use this app. This is what we're trying to fix. Okay, but let's talk a little bit about where the world data, and by which I mean things generated by sensors or map information or whatever, anything that is the world, like where is that today? So these are the big ones: camera pose, finding, detecting surfaces, hit test, meshing. For faces, faces is surprisingly advanced compared to most other types of world data. Thanks Snapchat, thanks Facebook. Like, hands is fairly far along for a limited scope. So if you have a specific device like the Leap Motion, you can do pretty well on hand tracking, but it's by no means ubiquitous. One cool thing about both Snap and Facebook's face tracking algorithms that I'll mention is they are hardware agnostic, which is unusual. They don't need depth cameras. They work on like old crappy Android phones, which is pretty amazing. Relocalization, 2 and 3D markers, which can be image or 3D models with Euphoria, object recognition, light estimation, body tracking, and depth information if you have a depth camera or a really good algorithm. Matthew Shona, my team, made this enormous chart of where we are now. Starting off on the software side, you see Euphoria has probably the most to offer of any available software out there right now. And then 60 AI is new to the market. We're doing some beta testing with them, and they're pretty great. And they have really, really fast meshing. I'm not going to go through the whole list, but this is a sense of where things are at in terms of what's widely available. You see a lot of this on mobile, and a lot of it is mobile dependent because they're also using either CoreML or TensorFlow. They're actually tied to the GPU. And then a little bit with markers and so on. But you see there's some gigantic gaps in the offerings here. And a lot of companies tend to focus on only one specific type of object recognition, or sorry, of computer vision. And then on the hardware side, we have a lot of stuff that comes for free with different either hardware providers or software providers that are heavily tied to hardware, like, for example, ARCore, which is, in theory, sort of device agnostic, but obviously is tied to the Android platform in general. And it's filled out a little bit more. But you can still see here that, you know, object recognition is nowhere near. And this is interesting, too, because I think people see it once and they just kind of assume it's everywhere, right? Like, you see that the iPhone X has face emoji, and you think, like, oh, cool, that's just available in the world for anyone to use. And it is if you have an iPhone X and or if you use or license another type of software. But it's not available for most people. And more importantly, it is not available to author against in the Unity editor, which is a big thing for us, because we want people to be able to be making the face mask in the Unity editor and actually see and preview what's going to happen without having to build to the device over and over again. So a large part of my conversations with companies like this is asking them how we can get most of that pipe straight back into the Unity editor to actually build against. The same way if you're in a game, just imagine trying to make a game if you couldn't see what the level was and you had to try to guess, right? That's where we're at with a lot of augmented reality authoring right now. But, you know, it's all coming slowly as the libraries are fleshed out. Right, okay, so I touched on this a little bit just now, but I also do want to point out that a lot of machine learning stuff is really tied to the hardware. I mean, NVIDIA is killing it in terms of GPUs specifically for machine learning, which is awesome, but it does mean that you have to, whereas developers used to just have to sort of choose a platform, now there is an additional hardware component that wasn't before, especially if you want to do something bespoke. All right, so this is where Mars is today. You got a sneak peek of where it is in the future. But through this process, we decided that basically everything about how we know to interact with computers will also have to be rethought. And so I'm going to segue now from the developer tools we're building out to the types of things that we want to support across the board. So when it comes to the way we deal with computers today, for one thing, for example, your email is kind of your passport to the world. Your email is used to verify almost any account you sign up for. It's used to send things to other people. Like, your email has a very strong, like, almost ID-like quality to it on the internet. And this is just how we sort of set that up. So we need to figure out ways, when I'm wearing a device and you're wearing a device, I shouldn't have to send you an email notification in order to friend you or to give you permissions to see Google Maps on my device, right? We need to either rethink how those permission sets works or come up with new interfaces for them. And that has to work across different OSs as well. Either that or the whole thing is going to kind of be broken and isolated and suck for a while. What permissions are, location, actually. So right now when you think about permissions are entirely tied to the individual. I choose what I share with you, but it's all related to me. I might share my health information, or I might show my browser history, or I might share, a cute cat photo, but it's all about what I want to share with you. One interesting thing about permissions for spatial computing is now they have another dimension, ha ha ha. But literally, like as in when I walk into a space, it might have a different permission set than the space that I was in the minute before I walked it through that doorway. And I'll go over that in a little bit too. App discovery and minimization, et cetera, et cetera. If you don't want to have a cluttered world around you, how do you find out that things are in the room with you? Modes, world space versus user space versus object anchoring. How do we come up with a set of standards so those developers can quickly make things that work in different types of environments? And a big one is that we need to tell computers things that we never normally talk about or even think about. I'll mention that in a second. And we also have to have new ways of easily dealing with inputs and talking with computers in general. So yeah, we need to tell computers things that we never normally articulate or even think about. This is a really interesting problem. We need to explain things to our computer like, what is my house? And who owns what in my house? And this is my bedroom, and what can you do in my bedroom versus not? And this is my kid's bedroom, and what can they do? Oh shit, I don't know. Do I even want to know what they do? Right, like, this is where we're at. Everyone has a way that they interact with everyone they live with, and a lot of it is unspoken. And it's very strange to think that we are going to have to articulate this. And I don't know if any of you remember Google Circles, but that was a great way to try to easily move people you know into very friendly and open and overlapping groups, and no one used it. Still failed, because there's a lot of things you just don't want to have to. Once you put it into words, once you make it real, it feels a little bit too real or a little too socially awkward. So we can use machine learning to glean intent and to glean purpose and to sort of make assumptions, but in the end, we need to have the user have the ability to make the changes to anything that we have assumed for them. But before we get into, we'll talk about permissions specifically, but before we get into that, I want to talk a little bit about how people talk to computers today with modalities. So modalities are just sensory input and output. The big three are visual, audio, and touch for computers. Obviously, you have smell and taste, but those are gross. I don't want them on my computer or involved with them. Affordances are the things that tell you what you can do. Inputs are how you do the things. And then finally, feedback is output. That's confirmation that the thing you did actually worked or didn't work. All right, and as I mentioned, these are the big three for computers across the board. Almost any kind of computer that you care to mention will probably have some combination of this, unless like you're playing a theremin maybe. Visuals are poses, graphics, text, UI, all of the feedback stuff. iPads are giant visual feedback loops. Auditory, and then finally physical. Okay, so with the rise of sensors, especially for world data, we also have a bunch of cool new types of inputs that are, a lot of which are biometric. And the cool thing, an interesting thing about these compared to the big ones that we're used to today is that a lot of them work a lot better if people don't consciously know about them or think about them. So for example, breath, like unless you're gonna, and I've seen these before, people make like breath games, and they're fun for a little while. But if what you want to know is a user's mood or their intent, you want them to not be thinking about their breath because that will mess with your data. Tracking unconscious limb movement specifically is really interesting. Magic Leap has now done some talks on how they can sort of use a combination of eye tracking and hand velocity to know exactly where the user is going to select, which means that you can almost have this magical way of something happening before you've even started to think about it. Pupil dilation and body micromovements, all of those are usually go back to mood. There aren't a lot of other major use cases that have come up for these yet, but they're all kind of part of the whole, how am I feeling? Am I annoyed? Can the computer fix it? So what works best when? Right now, when you are learning something, visual is the fastest way to get information quickly, right? Which is why Alexa is a little annoying when you ask it to buy something and it gives you like a 20-second response about what did you actually want to buy. But it's best for learning, but it's not best for everything. I'll talk about it in a second. So it's great for affordances, letting you know what's possible. As an action or input, it's poor. It kind of doesn't exist. Visual input per se, maybe eye tracking you could say is a visual input, but it's not really a thing. And then for feedback, it's fine. It's about as good as the rest of them. For affordances, audio is also very good, and audio also has the advantage of being omnidirectional and hard to opt out of unless you've actually muted it. If the audio is on, the user really can't avoid hearing it. For action, it's fine. I'm going to give it a good because it will be better in the future, but right now voice commands we all know are not that great. But for feedback, it's actually really excellent because audio has a cool bonus side effect in that it's so tied to the physical that if you have an audio feedback, it also kind of feels like there's a little physical push there, and you can use it. It's used very often in virtual reality. Same is true for augmented. Physical is a poor affordance at first. Like if I'm learning to type or I'm learning to use a mouse or something, people will always look at it in order to get the muscle memory mapping, but later on it'll be good. For the actual action itself, though, it can't be beat. It's really nice to have both. And for feedback, having a little bit of haptic feedback is good. Someday in the future, when we all have full body haptic body suits on, I guess, maybe, it will also be good. But it changes when you're in mastery mode because visual feedback does need to tie to muscle memory, but after a certain point, when you get in the flow, you want to have everything solely in muscle memory, and you don't want to have visual feedback at all. Or sorry, you don't want to have to depend on visual affordances at all. So when you are good at typing, when you're good at playing an instrument, when you're good at driving a car, you no longer have to look at it in order to do it. In fact, looking at it can actually distract you. So once you're in the flow, once you've moved from the prefrontal cortex processing part of the brain back to the limbic system where the muscle memory lives, then you tend to be the most fast at whatever you're doing and the most accurate. And this is why no one can type well on their iPhones or iPads, because you can never have muscle memory on an iPad. All right, I also just made this little diagram just to walk you quickly through an example of how to think about this sort of systemically. And the example I'll give you is from a game console with a controller. In this case, this one's specifically from one of the Legends of Zelda. Not Breath of the Wild, another one. Anyway, okay, so you start off, most of the affordances is largely visual. Oh, in this case, it was a tutorial about how to swing a sword. So you go meet the old man, and he gives you a sword, and he's like, cool, we're gonna learn how to swing the sword. Hit the B button. So very, very visual feedback, and there's a picture of your B button there, and a little bit of audio, right, the sound there. And then the input is entirely physical. The example I had was from an earlier game where there was no haptic feedback. And then once the button is pressed, you get the swish of the sword, you get the audio feedback, and then you also get a lot of visual feedback. And if you do have a haptic controller, you might get a little pushback. So I just show you this to give you a sense of, I think people often think of this as one or the other and don't think of it as this continuum. So I'd like to have people start to think about how can they hit all three of these for every type of interaction. And this is much more important for spatial computing, I think, even than 2D stuff, because so often you're going to have feedback on interactions that you are not looking at, so you need to make sure that you cover all the bases in every part of the modality loop. Okay, Another quick segue on how inputs become popularized. When it comes to PCs and game controllers, we've been pretty much standardized since the 80s, which is crazy. We've moved over into gestural stuff, but a lot of that has correlations from earlier inputs. There's a lot of one-offs, and they're really cool, and I'm actually really excited to have a lot of custom, cheap peripherals that are highly tailored to the user in the future. But for now, the way that inputs become popularized, for example, we had a tablet and pens since the 60s. But in 1974, they cost $18,000, whereas a mouse cost $450. A mouse got down to $30 and was shipped with a Macintosh. It wins. We don't have styluses ubiquitously to this day. So they have to be cheap, reliable, behave consistently. They have to have an acceptable error rate, which answers the earlier question. If we can't type on our iPhones well, why do we all continue to use them? Because it's good enough and we have spell check. They have to be physically comfortable. I found this amazing screed online, 16,000 words from 1982 about how all game controllers sucked and how they all gave them blisters. And I was like, man, I can't even imagine having a game controller today that gives me blisters, but that was the 70s for you. And then obviously you need to have software that supports input. And I think this is why a lot of cool inputs don't take off today, because you might go to a trade show and see some really cool new keyboards or new ways of having spatial mice. But if you don't have software that takes advantage of it and actually works better, it's probably not going to take off. OK, so getting back to we need to tell computers things we never normally articulate or even think about. Let's think about them. OK, so the first is permissions. And this is not set in stone, and I love to have conversations around how we should be defining this or making this more granular or thinking about this. So if you are also thinking about this and you think what I'm saying is wrong, I would love to talk to you about it afterwards or have a call. All right, so we'll start with public. When it comes to spatial computing, again, think about, we're all in the future and we all have wearable devices or brain implants or whatever do we have. The public sector is going to be the one that could be the most nightmarish and dystopian, and will, like invest in ad blockers today because they're going to be big in the future, right? But it also has a lot of positives because this is our opportunity. When humans have the capital and the resources and the ability, we make beautiful, beautiful things. And I think that this is really a way that humans can create a beautiful world for everyone. And so in that sense, I'm very excited about what will happen in the public spaces. But it also has some weird things around licensing, for example. I went to Europe over the summer, and the new privacy rules had just rolled out, and I used Instapaper all the time. Do you guys use Instapaper or know what it is? Lets you save articles. Anyway, yeah, and I couldn't use like my favorite reading app when I was in Europe, and I was so annoyed. And imagine that for augmented reality. It's going to be extremely annoying, so we have to rethink that. Controlled spaces. So these are semi-public spaces that are usually available for anyone to walk into, but that are owned by a specific entity, not a corporation, not a government. Places with a commercial owner. So that begs the question: who owns what you can do with these spaces, right? So if I have my iPhone and I walk into a Microsoft store today, I can check my Apple email, no big deal. But what I couldn't do is go put like a big Apple logo in the middle of the Microsoft store. Right? If I did that, they'd be like, what are you doing? Stop, get arrested, whatever. But in theory, I could do that in augmented reality and do so extremely easily. I could just like draw it with my drawing app and be like, tee-hee-hee. And the AR trolls are going to do that. They're definitely going to do that. So again, going back to things that we're going to have to articulate to computers, corporations are going to have to think about what can people do in our somewhat public spaces, right? And they're going to have to come up with ways to either block everything everyone does unless it's permissible, or give people permissions on the fly. It's just, there will be a solution, but it's going to have to be a new solution, not a new level of thinking that we haven't had before. Another thing is that these spaces will be good. Spatial computing, I'm talking about wearables a lot because that's, I think, an easy thing, and we're all sort of on the same page. But I've also seen a lot of great work being done with holograms and projectors, specifically, especially projectors that have depth mapping. Lightform is on the floor today. I'm not sure if people have seen that on the exhibition hall, but that's another good example. So I think that this is something where that will take off just as well or easily as wearable devices. And obviously, IT guys are going to have a hell of a time with all of our hologram Skype calls. It's hard now. It's going to get harder later, I think. All right, and then intimate spaces are very personal spaces, whatever you want to call it. These are apartments, homes, cars. These are the places that we call our own that belong to the individual. Right now, we have ads in our home all the time. Like I watch YouTube, and there's a 5-second ad that I can skip. We actually live in a cool period of time where we have less ads than we've ever had, really, that you could opt out of very quickly. You know, you used to listen to the radio, and you just have to suffer through the ads or listen or watch, broadcast television. So I don't think this will be huge and dystopian and terrible, and I'm almost sure it probably won't even be a class-based issue the way Black Mirror would indicate. But again, it's something we're going to have to be comfortable with because ads will become larger and more immersive and therefore more invasive, right? Like if an ad is a giant dinosaur walking across your living room, that sounds awesome. But do you want to have to see that every 15 minutes? Yeah, maybe not. All right, and also I touched on this a little bit earlier, but people's rooms tend to be their sanctuaries, right? And that's kind of the place where you can be yourself. And if you have roommates, or if you have children, or if you have, anyone living in your home besides yourself, frankly, it'll have to be a conversation that you have. And then finally, private. And private is kind of the thing that we're most used to today because it's not exactly spatial. Emails, diaries, passwords, finances, porn, dating, health, job info, all of the stuff that you know yourself and that you choose to share with others. So this is funny. I was arguing with one of the lead engineers, Jono, about, I'm like, sometimes this can't be the top tier permission. And he's like, no, your defaults should always take over everyone else's defaults. And I was like, I don't know. And the last time I gave a similar talk, someone actually came up with a great example where spatial permissions should override your individual permissions. And that is when you are in an unsafe space. If you're in a factory, or if a road is closed, or if there's some sort of warning that you need to have, it doesn't matter how much stuff you've blocked, you must need to see it. And so there are certain cases where it can override it. But for the most part, I would say this is probably going to be the top tier permission system that you start off with. But it does require a lot of cognitive load. It requires you to think about how you want to place objects and how you want to see ads and how you want to interact with other people. I think we have ways we can work around this and sort of infer intent a lot of the time. But people are very comfortable sharing things on their phone on an opt-in basis without thinking about, because it doesn't exist. If I show you my phone, it doesn't mean that we're friends on a social network, right? It doesn't mean you have access to any of my history. I just showed you it briefly and then went away. But in order to transmit and calibrate data on a scale where we're both looking at the same thing at the same time instantly, it's going to require another layer of computers and networks talking to each other. So we'll just have to think it through. All right, let's talk about interactivity states. All right, so that's the permission set. Now let's dive a little bit more into how we think things will interact with each other. So these are the 4 that we have right now, and I'm sure there will be more in the future: active, semi-active, remote, and minimized. So active is, the most interactive. Like, this is what happens when you're actively interacting with your email app or your Netflix app or your Princess Leia hologram app. So this needs to be a state. Like, what does it look like when everything's completely opaque and full-sized and in the space and you're working with it? Things can also be minimized and still be fully interactive. For example, if you have a music app, you can maybe have the interface not showing, but you can still grab or click or do something and still have it go on to play the next song. And it also needs stub states for multiplayer, multi-interactivity levels. So for example, I'm watching Netflix and let's say we're watching Game of Thrones. We're both watching Game of Thrones and we both have it pinned to the same wall and we're watching it at the same time. So we're in a shared space and we're both feeding into the same app, calibrated. It's pretty much like watching TV normally, except I'm also browsing. So I have another UI that's also open and mine's in browse mode, but you're just passively watching. Semi-active. So this is when you have kind of things chilling around in the space that might not be turned on, but you want easy access to, pinned to yourself, pinned to the environment. And the reason this needs to be clearly defined is because you're probably not going to want it to be at full opacity or full size or full audio. You're going to want it to have a state where it's sort of in rest mode. And I think, 2 things here. I think this is really essential. Like, people don't think about this a lot today, at least not when I'm talking to them, but I think it's pretty essential to have a good experience in spatial computing overall. And we have something we call progressive disclosure, where you can sort of define a series of intent-based metrics to make the app get bigger and better as you get closer to it. So if I have my little dragon app, it's in the corner and it's kind of sleeping and it's semi-opaque. If I look at it, it goes into wake-up mode. If I start to walk toward it, it goes fully opaque and starts walking back towards me. Right? That's 3 different substates that are all in the semi-interactive state. Remote, so this one is not like a state necessarily per se, but it does exist within a state. So basically, let's say you have a Nest app that you have attached to you, and you're changing the thermostat, and the actual Nest thermostat is over there in the corner. What you're interacting with could be part of the actual Nest app if you were near it, but since you're over in the room, you've got sort of a remote subset of the UI that exists. Yeah, volume controls or next and previous, all of these things are obviously good examples of remotes. And it can interact with any of the other states at any other time as well. So it not only is a state in and of itself, but it can exist with the other states. And then finally, minimized. As I mentioned, you need to figure out how you can discover minimized apps. We've done some work with mobile AR where we have these sort of color hues at the edge of your camera feed, so you sort of know if you go this direction, you will find an app over on that side. But it has to be, you have to make a decision too about, is it anchored in space? Do you find it over here, or is it minimized next to your body? And do you have a series of things that you can just kind of pull out and put back? And yeah, it can't take up too much visual room, but it has to be able to be found. And this begs the question, do we need an inventory if I leave my, my Google Docs app in my house? I need to be able to get it at work, right? Like, sure, it's spatial computing, it is spatially into space, but I need to get it anywhere I want to. So do we need to be able to basically have the equivalent of a game inventory? All right. And then also location, which is sort of a state and kind of not a state, so it gets its own thing. Objects can be anchored to the world, the actual world. They can be, fireworks anchored to the Eiffel Tower. No, that's not a good example. They could be anchored to a street and anchored to an object like the Eiffel Tower, or for example, like this water glass. I have a GIF on here that is an AR ad that is anchored to this particular water bottle. And then in transition, this is when you have basically a UI that's being moved around, right? So it's going from here to here. It doesn't really exist anywhere. It's kind of anchored to your hand, but it could be anchored to your gaze. It could be anchored to a controller, whatever. It's just sort of existing, but it's in transition. And then finally, anchored to the user. I think those are pretty self-explanatory. Don't need to get into those too much. So this is how we're thinking about all of the different things you have to think about for spatial computing. And some of these have correlations to the way we think about games today and the way we think about applications today, a lot of the web. But a lot of it is, if not completely unthought of territory, certainly not standardized territory, certainly not things that we have all the answers to today. And importantly, a lot of the infrastructure for this does not exist in any form today. And we will need to either build it or ignore it, and therefore kind of fuck up spatial computing across the board. One of the things that has come up since I made this chart that I need to add to it is that we're starting to seriously consider grouping different types of UI. And this sounds a little cosmetic, but I'll tell you why. When you can easily imagine a world where you've got 2 different types of UI, and you can imagine it because my computer is it. You've got my display here, and then I've got the things that I interact with down here. Now, in the future, I think it'll all be of a piece. You could probably interact with most displays, but let's say you don't want to. You want it to be a piece of art. You want it to be a film in a public space or something. So you can have a display-only UI. And then you can have interactive-only UIs that have, well, not only, that have some amount of displays, but they're primarily interactive. And the reason this is important, and we think more things like this will exist, is because they therefore have certain inherent properties in order to be the things they are. So for a display to work, it has to be visible. You have to be able to see it. And that means you can infer certain things about the distance. It has to be away from the person who owns it or the person who's looking at it. And can it be too close? Can it clip? No, it has to be displayable. The same is true with interactive UIs, right? They have to be within arm's reach. They have to be interactive on some level. And so while these are kind of nested sets at this point. We do think that they're worth exploring as things that you can semantically define on the developer level from the get-go. Because that way, if you create an app where it has interactive elements and display elements, we can start to figure out how to cleverly place it for you at the beginning so you don't need to script, okay, it's a display. Make sure it's always at least 1 meter away and never leaves the viewport of the viewer. We want to make sure that that can be auto magic. And you could override it if you wanted to, but why script it yourself if you don't have to, right? Okay. So yeah, we think there'll be more like this. And we think this is a really exciting time, and we are excited to help build these tools for you. This is one of our many mottos. We have like a lot of mottos, but this is one of the mottos. Reality is our build target. We build the tools, you build the future. Okay, so how we design these things, all of these states, all of these modalities, and all of these permissions, we think this is important, and we're thinking about it because we know it directly affects not only how people interact with computers, but what they think they can do with computers. And that's very important as someone who thinks computers and connected knowledge are the way humans it will help us evolve and become a better species. So we want to think about this the right way. Permissions and data collection are also something that's top of mind that we talk a lot about internally. But in the end, this is our guiding principle. Let's support users who want to interact the way they want to interact with their computers. So we know when it comes to spatial computing, we need to have an incredible variety of modalities supported because it will be so personalized. It will be something that is connected to you instead of a device that gets stolen once a year in my hometown of San Francisco and I have to just blindly replace. We want computing to be more accessible. So rather than box the user in, let's support them however they want to be supported. All right, and that's all I got for now, so thank you very much. Yeah, and feel free, reach out to me directly at Timoni, reach out to the labs team, follow us on Twitter. And I think we have like a tiny bit of time for questions. Yeah, okay, if anyone has questions.
Yeah, I had one question specifically around the mixed reality SDK that you were showing earlier. Mm-hmm. And my question was around debugging. So when I run the simulator view and I see that the spaceship fits nicely on the bed, and then I go into the real world, but it doesn't. What are you guys doing around that space?
Yeah. If I just go way back, I think you can see in this mock. If not, I can try to. Yeah, OK. So you can see here that there's supposed to be a treasure chest, and the treasure chest didn't meet the requirements for this room. So it's subtle, and we've been thinking about ways to kind of show a ghost of where it should be placed or where it could be placed. It gets a little hairy there, but we'll just basically have the same thing for the on-device tools.
So you'll be using like a visual representation when you're in the real world showing that something is missing, or what you expect to be there isn't? Yeah,
so it's a little janky. Right now it'll just be like a list, like missing, and then you can sort of go in and change the properties. But actually, our intern this summer is working on a way to be in a space and then add new objects to a space to test against different types of things. So you've got 3 chairs, but you need a 4th chair for whatever it is you're doing. This is actually a real-life use case we had recently. And then you can just put in fake digital objects that will pretend to be real objects.
Cool. Thank you.
Yeah. So if you're at your desk and you're making a bedroom app, you can just have a fake digital bed. That's.
Just in terms of editor XR and the Mars project there, does Unity have any plans for integrating sort of mixed reality compositing functionality into that, so you could set up a camera and see a person like dancing around?
Yep. In VR? So in the simulation view, if you have recorded data, you can play it back in the sim view. So you can get and record like plain information from an iPhone. We also, at the demo at Unite LA, we showed face tracking specifically. So we had a camera feed. We used ULSI, which works on PCs. And you literally could just stick stuff on your face and go from there. But yeah, it's fun. But ideally, you'd want that for any other recorded information that you had. And we can record it and play it back now and be like, cool, here's a plane here that was found from an ARKit or core or meshing from HoloLens or whatever. But ideally, you'd be able to just actually run it over and over in the PC too.
Cool, thank you.
Mm-hmm.
I'm just wondering what you envision for multiple apps running concurrently across multiple devices, if you have like a Unity launcher of some sort, or would it be an OS-specific thing?
Are you saying, like, how would we want to,
Like,
how
for
would that
example,
work?
Magic Leap has like the Lumen OS, I guess, that can run multiple apps at the same time, but on other devices that don't necessarily support concurrent applications, would you?
I think that's kind of the $64,000 question for AR right now, is where does all of this live across different platforms? So Magic Leap has two different ways of thinking about applications. They have apps that, as you mentioned, can run concurrently in the same space, and they have pretty significant requirements around processing power and bandwidth and what you can do and when they flip off and on, just because mobile hardware is still in its infancy. We have done prototypes around work of how you could have a whole bunch of Unity apps running in the same space at the same time. But that gets into the OS land, basically. That is what an OS is. So it's an interesting time for augmented reality, you know? Like, we all know it's a problem. Every hardware manufacturer, every person in the space knows that this is an open question. Does it all end up becoming a browser? Does it end up being like GeoCities back in the 90s? Probably some of both. So yeah, we'll see how that goes.
Thanks.
Back to the privileges kind of idea. There's a company that's in LA called Versus that's working on a protocol for owning augmented reality space. Have you guys considered working along those lines?
By owning, do you mean that they are mapping and then rewarding users for mapping or meshing the space, or are they licensing it, or what's their?
So it's all pretty new, so I'm not entirely sure.
Yeah.
But it's kind of ownership over a virtual space, kind of like you can own.
So you claim it?
Yeah.
It's like the Wild West all over again. I've heard of.
Or like, how would that conflict with the direction that you were talking about?
I mean, unless it's ubiquitous mass adoption, in which case we're all on the same page, it won't. So the ones I've heard of have been mapping, like Ubiquity 6, for example. You go out with your phone or with your device or whatever, and you map, I don't know, what's the park over there called? The Stanley Park. Hugo maps most of Stanley Park all along the waterfront, and then you as a user are rewarded. Certain companies might give you, you know, like it's on the blockchain, so you are always the person who was the first person to do Stanley Park, whatever. It's kind of Foursquare all over again, right? Crowdsourced world mapping. But again, unless people pump into that as a provider of that world data, it doesn't make much of a difference, right? Because if they decide to use another provider for their app, they decide to go with like Google Maps or something instead, and be like, on Google Maps, I own this, then I'll, yeah, there's no clear winner in this space, and not a lot of people are even trying right now. So we're happy to work with anyone who wants to work with us to make sure that we're not doing anything weird there, but we're going to primarily all just be software providers from our perspective.
Question around consistent user experience. So currently, obviously, I download an Xbox game. It's the same on your system, my system. But now in AR, our environments are completely different, potentially.
Right.
What kind of tooling could there be for Unity, whether it's machine learning or something, to give me some general environments, or kind of build that consistent user experience in an AR environment where there's a lot of questions around what that would even be?
Well, the simulation view is designed to help you, or at least help you test, right? Because you can put anything in that you want. One thing that we're going to try to do is start collecting data around how people start placing things in the simulation view, because that can help us to generate a data set we can use to smartly place things by default in the space and try to help you out in that sense. But that's in its infancy, but we think that that's a great way to get a lot of really fast feedback and iterative loops without having to go to the consumer runtime experience and get the data there too. Because they're basically doing the same thing. You're just moving stuff around in space. It's just a fake space as opposed to a real one. But in terms of consistency overall, one it depends on the game, depends on the OS, whatever. I think a lot of that will be determined by the platforms themselves. But one thing I do think is going to have to be pretty ubiquitous is describing what types of digital objects are usable, manipulatable, and not. So if I can move my phone app, there has to be like a way of expressing that that's movable. But I can't move, the augmented reality movie attached to this, right? Because it's an ad. So there's going to be a lot of examples of things like that, and I think that's something that's going to be a standard and a semantic label from the get-go.
I want to look back to the hardware question, especially about what kind of hardware Unity would like to support or commit to support, especially in the AR head-mounted device area, because now my understanding is you guys are probably going to support Windows mixed reality and also maybe HoloLens. But like where the bar is, like nowadays we see lots of headsets just pop up left and right, but they don't really have like a very good engine integration support. So what's Unity's plan to support those kind of device, and is there any route towards like this kind of rendering device?
So I'll answer that question two ways. Unity supports a ton of platforms, right? That's like our bread and butter is that you can use Unity to go out to anything. But it's a little different when the editing environment is the hardware, right? Like that's kind of the flip side that we're only starting to think about. As the labs team, we get a little bit of leeway to choose who we want to support and why. They almost always tend to be major hardware partners that we also have large-scale business relationships with. So for Editor XR, we focused on the Vive and the Rift and made it possible to easily port over to Windows MR. Windows MR came out a bit later when we'd already switched focus, and that's the only reason why we don't have full support, because it's a pretty small team. That seems a little arbitrary. If anyone wants to do the port, we will get it back into Editor XR. Just put it out there. But in this case, the Magic Leap is fairly new. HoloLens is, if you're dealing with anyone who's trying to do anything audacious in the wearable AR space or anything for industry or anything that could be productized, it's pretty much going to be on the HoloLens today. Therefore, we will support the HoloLens. It's kind of a no-brainer. And we also already have a relationship with Microsoft. But if someone comes out of left field and just has some sweet hardware, we'll like stay that evening and get it working for fun. So.
Hi. So as somebody, I'm on the spatial mapping team at HoloLens.
Oh,
so
there
as
you go.
somebody from one of those platform teams, what's sort of like on your wish list that you wish the platforms could give you guys to help you out?
I want better inputs for the HoloLens.
Yeah, for that.
Yeah. We actually just had a call with some folks probably on your team a couple weeks ago, and we're actually asking what you wanted from us. So, the build process could be better. I think that's probably on your roadmap already, is my guess. So, yeah. In terms of, I guess just, I don't know. We could talk about it offline, but I feel like the HoloLens I always think is a really fantastic software and hardware stack. Like it's just phenomenal the amount of work you've done. So kudos. So in terms of wish list stuff, a lot more sensor information, but the controllers are really the big thing that I feel like is gets in the way of adoption. That and the price tag, but yeah.
You mentioned that the Mars object was built on game object. Is there any like roadmap or planned support for the entity component system?
Yeah, it's funny. I kind of fudged that a little bit. I was going to say something else, but then I checked with Andrew Maneri today, and okay, so yeah, game objects have certain properties that AR objects don't have, namely world space position, but there's some other things too. When you think about it, you've got a digital representation of an object here, the car, but then you also have a digital representation of something that is not an object, and that is, in this example, that is these planes, right? They're not real. They're not like a thing. They look like a thing. They look like a plane that has been found, but instead they are just the answer to the question. They are the result of a series of conditions where the query has been asked, and this comes back with a result. So what is that? Right? Is that an object? Kind of, it looks like an object. It has sort of properties. You can manipulate it. You can move it. You can do all those other game object-like things. but it is not in and of itself an object. So we are playing around with, is a AR object the game object that has AR properties, and we just ignore this entirely? Is this something that we call a Mars entity? Because we're firmly in lockstep with ECS, and a lot of how you set up your queries and conditions is essentially ECS-like, and that you have a set, or you have a system, and within that system you have components, which are the conditions, and then you have an entity, which is the instance of that. So yeah, it's on our radar. We try it out. We think they're doing great work, and we've already also implemented some work on the back end around semantic trait stuff specifically.
Thank you.
Cool. All right. Thank you all so much.